Morning. How's everybody doing today? Looks like we got 5 people out there. Say hello if you're in the audience. Hope you're doing well. Look at that. We've got 6 people. All right. We got some guests showing up today. It's good to see you, everybody. Welcome back to week 3. We have got, wow, we are 2 weeks down and 6 weeks to go. So we're a quarter of the way through the class. Good morning, Renee. Good morning, Erica. Good morning, Alexandra. It's good to see everybody. I want you to know that I stayed up late last night going back and fixing everybody's homeworks as you turn them in. I should have given a little more direction on the hotspot quiz items, and I should have made the boxes a little bit bigger. But I went back and made sure that everybody's was graded correct. Go ahead and take a look just to make sure I didn't miss anybody's, okay? Good morning, KB. Good to see you. And I also updated the attendance. It's a little crazy trying to keep track of everybody going different directions. So go back to your collaboration grade and make sure that I gave you full credit for your discussion board if you did it, and make sure that I give you extra credit if you also came to the live webinar as well as doing the orientation. Okay, sometimes I do make mistakes. I've got 85 of you, so please check behind me to make sure that I get it correct. Okay. I did want to make one quick announcement before we get started in today's lecture. I was thinking about the timing of the first exam, which is coming up this week, and I had it set so that it was done at the end of week 3 so that we could start fresh on week 4. But I realized that I've also got you turning a homework in on Sunday as well as doing the final exam, which is due on Sunday. Also, I know a couple of you work all weekend. So what I decided to do was to extend the exam date out one day. The midterm and final exams will not be due on Sundays, but instead will be due on Mondays. All right? So your first midterm exam will be available Friday morning at 6 a.m. and you will have all weekend to do that exam all the way through Monday night at 11:59 p.m. Does anybody have any questions about that? Does that make sense? I hope that helps people out. I talked to Donnie Hahn. I don't know if you're here today, Donnie, but Donnie works weekends, and so this will at least help him. Hopefully it works for the rest of you too. Okay, if you would, let's go ahead and get started on the on today's lecture. But before we get started on the lecture, I did want to make one quick announcement. I wanted to congratulate the winners of this week's Kahoot. So here we are on the leaderboard, and you'll see that we've got Madison Gregitis in the lead this week. She took it away. KB, your win streak was snapped at 1, and I see Donnie Hahn coming up 3rd place. Very good to go. Very good, Donnie. I appreciate that. Solid work. Folks, if you want, try to join the leaderboard here. It's tough competition, and we don't give away no stinking participation trophies in this league. You got to work hard to join the leaderboard, so I hope everybody does. Okay, so this week we're talking about Chapter 4 and 5, Developmental Psychology, which will be on the final exam. And we're going to break developmental psychology up into 2 chapters. Today I'm going to talk about healthy development, how developmental psychology has really increased the quality and span of human life. And then on Tuesday we're going to talk about 2 classic theories of psychological development. Erik Erikson's theory of personality development and Jean Piaget's theory of cognitive development. Today we're going to talk about why the developmental perspective is important, and we're going to talk about things you can do to make sure that your baby is healthy and happy. We'll talk a little bit about language development and attachment in infancy and early childhood. And, we're going to throw in, it's kind of weird, but I'm going to throw in a wild card. I'm going to talk a little bit about cognitive development in late adulthood. So these are all sort of health related issues that we're going to be talking about today. Any questions so far? Hopefully not. Cool. So, lifespan development. You know what? The developmental perspective is about 100 years old. G. Stanley Hall was the first person to designate this stage between childhood and adulthood we called adolescence. It used to be nobody really thought much about how human beings develop. We thought you were probably done at 7, 8, or 9, and then we sent you off to the mines to work like you were an adult, right? But in the last 100 years, we've developed what we might call the lifespan development, which is a multidisciplinary study of how people change over the course of their lifespan from conception to death. And we're interested in trying to figure out what it is that helps humans live as healthy and as happy as possible. And I've got a graph up here in the top that shows you what we call the rectangularization of the survival curve. And you see that the change in average lifespan has increased greatly since the turn of the 19th century. In 1900, the average lifespan, that is the age at which half of your friends would be dead, was 47 years old. Can you imagine that? And a ton of people died in infancy and early childhood. Today now, in 2000, the average lifespan was around 2020. That's actually a typo. The average lifespan is 79 years of age. And infant mortality is incredibly low. And you know what? 15% of our population is actually older than 65. So people are living longer on average than they ever used to. And you know what? There is evidence to suggest that in some countries by 2030, the average lifespan, the age at which half of people in your cohort die will be 90. Can you imagine if you just expected to live till at least 90? It turns out that death, that your likelihood of dying is really dependent a lot on your behavioral habits and not as much as on your genes as you would think. So you need to eat the vegetables, get outside and start exercising and living that happy life. Now, developmental psychologists focus on how human beings change in 3 broad areas, all right? Because, again, I told you the other day we break psychology up into multiple parts because it's easier for people to focus on different aspects of human functioning. We have developmental psychologists, we have clinical psychologists, we have experimental psychologists. One way in which developmentalists think about human development is by thinking about how we change on 3 broad domains. How we change physically, how our brains and nervous systems mature from birth until death, right? How does our nervous system change? That's biological change or physical change. The second group of psychologists focus on how our mental abilities change. That is, what can an infant do? And how is an infant's thinking different from a 2-year-old's thinking? Who's different from a 6-year-old's thinking? If you've ever had a conversation with the 6-year-old, you know that they're not on the same plane as you are intellectually as a young adult, right? So we talk about cognitive development. And then we're actually going to talk a little bit about how mental abilities decline as we get older, right? We all talk about how we're losing our mind when we get to be my age in the 50s. But really, how do your mental abilities change as you get older? And then finally, we're going to talk a little bit about socio-emotional development. That is personality. How does personality develop as we get older? What important things are important for the development of our personality? And we're going to focus specifically tomorrow on a theory by Erik Erikson, which my nursing students have told me is very prevalent, is featured very heavily in nursing school. So if any of you are trying to get into the nursing program, you'll want to pay attention to the Erikson lecture. Any questions so far? Good. If you don't have any questions, I'm running on a pretty quick delay. I've got the latency set really low. Right, Ken? Cheers to the 50-plus class. You know what? Age is only a number. Just get out there, eat your veggies, and exercise, and you too can live to be 150, just like me. All right, so the most important thing you need to know about is prenatal development, how you can protect your babies for healthy and happy life, right? Thanks for the pep up there, KB. So we're going to talk a little bit about teratogens, which are environmental substances that can harm prenatal development. Just as I told you, there's a blood-brain barrier that protects molecules from getting into your brain and messing with your neural functioning. And I suggested to you that agonists, or psychoactive drugs, are drugs that are small enough to pass through that barrier to get to your brain. Teratogens are molecules that are small enough to get through the maternal blood barrier. So in the the umbilical cord in the baby, oh my goodness, in the placenta, I can't believe it. In the placenta, the mother's bloodstream and the baby's bloodstream never actually mix. What happens is small molecules that are healthy, like oxygen and glucose and other things that the baby might need, are small enough to diffuse through the mom's capillaries into the baby's capillaries. And that's how the mom feeds the babies. Now, these two blood systems are never connected, and that protects the baby from any bad stuff that the mother might come into contact to. So the placenta actually serves as a filter to protect the developing baby. Just like psychoactive drugs are small enough to transmit through the blood-brain barrier, drugs that are teratogenic are small enough to also diffuse through the mother's capillaries into the baby's capillaries, and these teratogens have harmful effects on a developing baby. So your book's going to talk about cigarettes, it's going to talk about alcohol and fetal alcohol syndrome, it's going to talk about the Zika virus, and you folks know all of the different things that you're probably supposed to avoid while you're pregnant. So you want to stay away from hard drugs, you want to stay away from caffeine, you want to stay away from alcohol. All of these drugs are what we call teratogenic. That is, they have molecules that are small enough to penetrate into the blood system and harm the developing fetus. Now, what determines the impact of these teratogenic drugs if you do come into contact with them? Well, of course, it's the dose, it's the amount of teratogen that the baby is exposed to. There's also a genetic component that determines how affected the baby is. But what I'm going to talk about specifically today is the timing. All right, so often the timing of the teratogen will cause different and more or less severe damage depending upon where the baby's developing. So babies develop through three broad stages of prenatal development. The germinal stage, which is where fertilization occurs and where they latch in to the uterus and begin growing. And once the nervous system starts developing, we say they're actually in the embryonic period. And from about 2 to 8 weeks of gestation, all of the baby's organs, arms, legs, stomach, heart, lungs, everything's going to begin to form. Now, it's not going to be done for 2 weeks, 3 weeks. Actually, the nervous system takes 25 years to fully mature, but every nervous system starts in the embryonic period. And then from about 8 weeks to 40 weeks of gestation, the baby's in what we call the fetal period. And really, all of these organs and systems are maturing, and the baby is growing in size. So, depending upon when you take the teratogen, it's going to have different effects. Teratogens in the germinal period and early in the embryonic period may cause so much damage that they lead to spontaneous abortion. Since organogenesis, that is the creation of organs, is occurring from 2 to 8 weeks, teratogenic exposure during this time will actually cause malformation of these structures. There was these babies back in the 60s. Ken, you may be old enough to remember these stories of the thalidomide babies from the early 1960s. Women were prescribed this anti-nausea medicine in the 1960s for about 3 months over in London, and it was stopped after it found that taking this drug caused the body's parts of the baby just to quit growing. And so you have these things called thalidomide babies who had no arms or would be born with hands stuck to their shoulders because these different body parts just wouldn't grow. So if you take teratogens during this time, it can actually cause gross malformations of the structures. Exactly, Ken. I remember the kid, I had a kid with pincer hands in my class. His fingers hadn't formed and he was stuck with 2 claws. I don't know if you remember something like that, but it was fairly horrific to see people with these kinds of teratogens. Now, teratogens after 10 to 12 weeks in what we might call the second and third trimester, they're going to cause damage, but they're not going to cause malformations as much as they're going to cause things just not to function properly. Or we're going to get low birth weight, or you're going to get a preterm baby, which is a baby born before 37 weeks of gestation. And there are negative effects associated with these kinds of outcomes. So I know people say, hey, you need to avoid these bad things while your baby is developing. I don't know if you've ever known why, but this is kind of the rationale for why you want to avoid these substances. They're small enough to slip through the protective filter that's built into the mother's placenta, and they have harmful effects. And depending upon when you're exposed to them, they can have quite different and more or less severe effects on your baby's development. Okay, now after that, I want to talk to you a little bit. Today we're going to focus sort of on biological development. So tomorrow we're going to talk about cognitive development and socio-emotional development. So I'm going to focus a little bit on biological development. Remember, we talked about the 3 areas of developmental interest. We're going to talk a little bit about developmental changes that occur in your nervous system, because the biological development is going to underlie everything else. If the biological system for personality doesn't develop, personality won't develop. If the biological system for memory and information processing, then cognitive abilities won't develop. So biology sort of underlies all of it. And I want you to know that your brain changes in 2 ways. One way based upon stimulation, and one way based upon genetic maturational change. Okay? The first, we'll talk about them briefly, one and then the other. The first is learning, or what occurs as a result of experience. Think about brain stimulation. You know, I meet a lot of parents that don't know a ton about developmental psychology, and they feel like they're not doing a good job raising their infant baby because they think like they should be teaching them Spanish or another foreign language or math, or what am I doing? What do I need to be doing with my baby the first day? Really, you know what you need to do with babies? You need to play with them. That's all you do. Because when you play with the baby, you're stimulating their brain. Whenever you listen to music or play a game or watch a program, your brain's being stimulated and your brain's growing. And what a baby needs during the first several years of life more than any other time is for their brain to be stimulated so the different parts can grow. How do they grow, you say? Well, it turns out that when one neuron stimulates another neuron, remember we talked about presynaptic and postsynaptic, every time a postsynaptic neuron dendrite is stimulated, it releases a little chemical that helps the presynaptic terminal button grow. And so as one neuron stimulates another neuron, that other neuron stimulates in a backwards way the growth of the first neuron. And so you're just like roots growing on a plant, your brain, as the neurons begin to stimulate one another, they begin to grow roots out towards one another and really starting to intertwine and interconnect with one another. And we call this process synaptic blooming. And it happens whenever you use brain circuits, but it really happens in an exponential fashion in early childhood. We call it overexuberant synaptic blooming. And then what happens is your brain begins to learn the best pathways to get jobs done. So it may make 6 different pathways to move your right arm, but then it finds one pathway is the pathway it likes to use. And then it begins to use that other one, and the pathways and the connections that were made that aren't used begin to wither away because they're not being fertilized by the postsynaptic neuron. So then you get what we call synaptic pruning. So your brain goes through this process where your dendrites and synapses are growing like crazy, and then they actually die off and create what we would call the fully mature architectural brain. They have the brain designed the way you want to use it. So your motor connection may be a little different than my motor connection, based upon how often you were stimulated, how you were stimulated, and how your brain was designed. And we call the process of the brain's ability to change in response to need neuroplasticity. So the crazy thing about your brain is if a part of your brain is you're born without a part of your brain, or you lose a body part controlled by a piece of your brain early in life, your brain will actually reprogram itself to work around the problem. I've got a video for you in this week's course resources folder about Ben Underwood, the blind boy who can see with his ears. And he lost his eyes to cancer when he was 3 years old. And as a result, he developed really good vision and hearing, and he started listening, and he can actually hear echoes, and he can echolocate like a bat. And he clicks, and this information that comes in through his ears has been rerouted to his visual centers, and he can create visual images in his brain using just sounds. He's a great example of neuroplasticity. Any questions so far? Now, I do have you watching a video this week about ACEs. And I hope you guys watch this. It talks about the negative effect that childhood trauma has on our physical well-being. And I invite all of you, yes. And which graphics are you talking about? The pictures you see here in front of you? Yeah, I copy all of the pictures from the textbook into the lecture slides to make it sort of flow as well as possible for you. But this week, I have a TED Talk by Nadine Burke Harris, who explains how early childhood trauma and neglect actually changes our body physiologically and can harm our physical development. So I'm going to leave the point down here that blooming or pruning or that neuroplasticity can be a good thing or a bad thing. Right? Now, the second change that occurs in your brain is maturational, and it does not speed up based upon your experience. And it's called myelination. So your brain is born with all of the brain circuits that you're going to need, all of the neurons that you're going to need. Why? But the part of your brain that's not present at birth, and why you're so helpless at birth, is you do not have the myelin tissue that goes around the axons of your neurons. That myelin tissue grows over the first 25 years of your life, it turns out. It grows most extensively over the first 5 years of your life, but your prefrontal cortex, your judgment and responsibility center, doesn't fully myelinate until you're 25 years of age. And that's why rental car companies and Airbnb won't rent to people under the age of 25, because research shows that you folks don't have as good a judgment as us older folks do. Right, Ken? Now, here's a picture right here of the myelination, just to give you an idea. Myelination occurs unevenly, and as areas become myelinated, they mature. And so the brown areas myelinate quicker, so you see the occipital lobe for vision myelinates, and then the motor and sensory cortexes in the middle part of the brain myelinate. And so children's vision matures, and their ability to run around and feel things matures pretty quickly. But what doesn't mature as quickly? Their temporal lobe. So little kids don't have very good memories, and they don't have very good thinking strategies. And actually, it turns out tomorrow we're going to talk about how they're not very logical at the age of 2 or 3. And you see their association cortexes, their ability to put sensory experiences together, doesn't myelinate first. And then you'll see here the frontal lobe is the judgment and personality area, and that doesn't mature until much later in life. In fact, it turns out, what we say is that personality doesn't really mature until your late teenage years. So I don't know if all of you were like me, but when you were 12 or 13, one day you were extroverted, the next day you were introverted, one day you were king of the hill, next day you were the worst human being that ever existed. And that's sort of that personality not being able to fluctuating because it's not crystallizing yet, right? And so those are the two changes that are going to occur in your brain. Now, here's the deal. We can't see inside your brain. Well, we can, but it's expensive and your insurance company isn't going to pay for it. So we need a quick and easy way to evaluate how well your brain is maturing. Mostly this myelination, but whether or not you're also having your brain stimulated. And so the concept of milestones allows us to evaluate children's behavior to assess the quality of their neurological development. Does this make sense to everybody? Nobody's typed in the chat bar a question or comment, so I hope I'm not losing you by trying to talk too fast. Okay, but milestones. So milestones allow us to see whether or not our child is developing normally in their brain. If they start missing milestones, we begin to worry about the child's neurological development. So a milestone is the ability that a child with normal neurological development should be able to do. All right, now we have milestone expectations. Over time, we've figured out how children's behaviors unfold, and it turns out that all over the world, they unfold in about the same order at about the same time. And so what we do, what your doctor does when you go into your doctor's appointment, is they evaluate your child. Now, some of them, like Fuqua Pediatrics, would give us this questionnaire called the Ages and Stages Questionnaire, where you would actually fill out a questionnaire about your child's milestone abilities. But if they don't do that, your doctor will just ask you to describe your baby, and they'll be listening for milestone behaviors. Their milestone behaviors. But what they're doing is checking to making sure that your child can do what 90% of other children can do. If your child can't, and your child is not progressing in sort of a linear fashion, the doctor may begin to get worried and start doing some further analyses to see if your child has a neurological problem. Because one of the things we know is that neuroplasticity can be used to help a child that has a disability. The earlier you identify and begin therapeutic techniques for a problem, the more you can leverage neuroplasticity to overcome your children's limitations. Now, what are milestones? Well, it turns out children are actually born with a set of reflexes. That's their first thing that they can do. And children with normal neurological development should develop these reflexes that they're going to later lose. So if you stroke a newborn's cheek, they should turn to the right and start rooting, looking for a breast. I know that's a stupid looking thing. Please don't share this video with your friends. Okay, that's the rooting reflex. Another reflex is that if you put anything in an infant's mouth, it's going to start sucking it. That's called the sucking reflex. If you hold a little infant up and dangle their feet are going to move, and that's sort of a walking reflex. And they have several reflexes, and these reflexes represent automatic adaptive behaviors that the kid has until their brain areas begin to myelinate. So milestone reflexes should be present at birth, but they should begin to disappear during the first 6 months of life. If the milestones don't go away, that might indicate a neurological problem. What categories of milestones is your doctor evaluating? Well, they're looking at your motor milestones, both your big muscles and your small muscles. It turns out children learn how to use their big muscles first. Their core muscles, they learn to hold their head up, they learn to sit up, they learn to roll over, and then they begin to use their fine motors or their small muscles. They'll then learn how to hold things. They'll then learn how to do this, a very important milestone called the pincer grasp, that's going to develop after the first year of life. And then we're looking at cognitive milestones, personality milestones. You know, your child should engage in their first social smile around the age of 3 months. Now, newborn infants may give you a smile reflex, but that's just a grimace, and that doesn't represent a true smile. But around 3 or 4 months of age, your child should smile when you go gidgy gidgy goo. They should give you that big old laugh and grin. And sometimes children with autism won't hit their socio-emotional milestones. So these milestones are a great way to diagnose autism. And then you have cognitive and language milestones as well. I had a young nephew who wasn't making his language milestones. They took him to the doctor, found out that he was partially deaf. They put some tubes in and did a little surgery, fixed his hearing, and his language caught up in less than a year. See? And so this milestone, him missing the milestone, allowed the doctors to be curious and to figure out his problem long before it interrupted his life. Make sense? So watch your kids when they're growing up. Okay, language. Turns out human beings do have what we call the language acquisition device. This is not a structure in your brain. Think of this as a capability. Everybody is capable of learning language. No matter how low your intellect is, if your brain is neurologically sound, you will automatically learn a language as long as you are exposed to one. It turns out that there are critical periods in your brain. Your brain needs to be stimulated at certain times for abilities to grow. And one of the most famous critical periods is the period for language. We all have a language acquisition device. We will all develop linguistic ability unless we aren't exposed to language within the first few years of life. You might say, well, everybody's exposed to language in the first few years of life. And how would you know? Because that's a horrible experiment to do. I've got a video in your resources folder about Jeannie Wiley, the case study of Jeannie Wiley. She had a crazy father who isolated her at birth and locked her in her bedroom in Southern California till she was the age of 13. He wouldn't let anybody go in and talk to her, wouldn't let anybody see her, and he gave her a pot to go poop in, and he fed her through a hole in the door until she was 13 years old. The police found out about it and busted in, arrested him, and saved her. They tried to teach her how to speak a language, and it turns out that Jeannie was never actually able to learn how to speak a language. So it turns out that there is a critical period. If you don't use that part of your brain to learn language, that area will be reallocated to another part of your brain. Now, in looking at your kids' language development, we're going to talk about the difference between receptive language and productive language. Your children will understand what you're saying long before they're able to say what they want to say. So your 7-month-old knows its name. It knows some of the things you're saying, food, bottle, etc., etc. It just can't produce them. So receptive language is always going to precede productive language. If you look here, I have the milestones for language. Really, the only one I think I've got on the exam or in the homework is the idea of the first word. Typically, kids are going to say their first word around the age of 12 months. Now, here's the deal. Some kids don't. If you spoil the heck out of your kid and you give them everything they need, and you never give them a chance to need anything, heck, they may not say their first word for an extra month or two. But as long as they're progressing through these milestones, your child is okay. They're going to start cooing, then they're going to start babbling. First word about 12 months. 18 months, your kid's going to start putting 2-word vocalizations together. More milk, want cookie. That's their first sentences. We call those telegraphic speech. Now, I don't know if you know this, but between the ages of 0 and 6, your child is going to learn 12 words a day every day. That is a ton of words. What you're going to notice is around 18 months to 24 months, your child all of a sudden is going to wake up one day and start being able to say a ton of words, and you won't be able to keep up with all the different words your kid's saying. And that's what we call a vocabulary explosion that you're going to see in the 18 to 24 months of age. And then from 3 to 5 years, your kid's going to go from being a crappy conversationalist to a pretty good conversationalist, because they're going to develop pragmatic ability. The ability to have a conversation, how to take turns, how to keep a conversation on topic, how to know if you're talking with a younger person. So 5 or 6 year olds will actually adjust their language to talk to a 2 or 3 year old because they know they don't understand them as well. So they're actually going to be able to adjust their language. And then you know what? Your 4-year-old's going to understand that maybe they shouldn't point out somebody's birthmark or the fact that somebody is overweight, right? They're going to learn what not to talk about. Okay. Oh my goodness, I'm running over. I'm sorry, you're going to have to give me an extra few minutes to get through all this content. We're probably going to go 11:45. I apologize. If you need to bail out and watch the recording, that's okay. One other important point regarding early life is the attachment process. There's been a lot of attention has been given to the relationship between an infant and a primary caregiver. Back in the 1950s, we talked about the bond between an infant and a mother, but it's not just a mother. It's whichever parent, male or female, related or not related, which the child chooses to bond to during the first couple years of life. Right? Now, and children during the first year of life are going to need a security figure to bond to. Like I said, doesn't even have to be a real parent. It just has to be someone there that they can build a sense of trust with. Now, the goal of child rearing, the goal of life is to give your kid the ability, the confidence to go out and search the world on their own. But in order to do that, you have to realize that the world is okay, that it's going to be an okay place. You've got to learn to control your emotion and your arousal. Little infants have these amygdalas and they get very scared very easily because they haven't, their system fires up and they don't have the cognitive ability to control their emotions. So it's very important that you make it so that the child can soothe themselves. And that's what attachment is. It's that close bond between an infant and a primary caregiver that lets the infant self-soothe in times of fear so that they can engage in exploratory behavior, because brains that are exploring are brains that are being stimulated, okay? So we need the baby to explore in order for the brain to be stimulated. So attachment is that close primary, that bond between the primary caregiver that really gives them the confidence to explore the world. Now, the first guy to study this was a fellow named Harry Harlow, and he studied it with monkeys because he wanted to see what would happen if you took a person away from their real mother and gave them the choice of a mother that fed them but was uncomfortable, or a comfortable mother that had no food. So back in the 1950s, it was believed that infants attached themselves to moms because moms had the breast and fed them. Okay, that was what we would call a behavioral explanation, and we're going to talk about behaviorism next week. But Harry Harlow actually thought that there was something more about that relationship. He thought that it had something to do with the soothing effects of having somebody who was warm and fuzzy. So he did this experiment. It's kind of horrible, but he took these infant rhesus monkeys and he separated them from their moms right at birth, and he put them into cages all by themselves, and he gave them one of two mothers to snuggle with. He gave them a warm, snuggly mother covered with downy material, really soft and snuggly, or he gave them a mother that was covered with wire but had a food bottle. And what he did was he would let the infant stay in the room, in the cage with these two mothers all day long, and he would measure which mother the baby tended to snuggle with. And he found that the only thing the baby monkeys did with the wire mother was feed from her. And then they would spend up to 20 hours a day snuggling on the warm, soft, fuzzy mother. And so he came to the conclusion that the need for the primary caregiver is not based upon food, but it's based on contact, comfort, and warmth. Now, as an upshot to this study, none of these monkeys ever developed normally. These monkeys were all really, really warped and had trouble dealing with adult monkeys later on. But within the context of this study, they did use this soft, furry mother as a base of attachment. Now, a follow-up study by a lady named Mary Ainsworth wanted to discover whether or not there were different ways that children bonded with their primary caregiver. This was largely a descriptive study. And she noticed that children go through these very normal anxieties early in childhood, but some children seem to have them more than others. Now, there are two anxieties that all children go through between the ages of 0 and 3 years. They're called stranger anxiety and separation anxiety. A 10-month-old baby hates to be separated from their primary caregiver. If their mom walks away to clean something or to get something, they will cry. You know, the only thing that scares them anymore, even more than that, is a stranger that walks up. And you'll see when a stranger comes up, most children beneath the age of 3 years old will run and hide behind their primary caregiver, or they'll be very fearful of the stranger. Or they'll demonstrate separation protest. They'll cry if their mom goes away. But some children seem to have a little more difficult with stranger anxiety and with separation anxiety and separation protest. So Mary Ainsworth created this experiment where children would be separated from their primary caregiver and put with a stranger for about 15 minutes. And during this experiment, they would be left alone by themselves, and then they would be with the stranger, and then they'd be reunited with their primary caregiver. And what she looked at was how they reunited with their primary caregiver. And she found that the children showed 3 very typical patterns of response to their primary caregivers when they came back in the room. About 50% of the children, she said, that were securely attached would run over and hug their mom and quickly stop crying. And then they would soothe themselves, and then they would go back to their normal behavior of exploring around the room. She found that about 20% of them, when the mom came back in the room, ran over and hugged her, but had trouble self-soothing or letting go of the mom. They would be extremely clingy, and she called these ambivalent children. She found still about 10% of the children demonstrated this other style where they couldn't self-soothe, but they did not seem to want the mother. They seemed almost angry at the mother. And she discovered, and she diagnosed, or she defined these children as being avoidant attachment styles. As being the avoidant attachment styles. And research has shown that attachment style and the first model that you develop for a close relationship may be a model that you use in adult relationship models. So if any of you have ever had a clingy relationship partner or a partner that didn't really want to get close or intimate to you, you may have had a person who had an avoidant or an ambivalent attachment style as an infant. And the upshot of this is that Mary Ainsworth suggested that the way you can create a secure attachment with your child is by being responsive to their needs. And I would add to that, not only do you need to be responsive to their needs, consistent in their needs, but you also need to be relaxed. Most young parents get so freaked out when their babies start crying. Yes, your baby's crying. Yes, it grates on that emotional nerve that you have. But what you have to do is you have to be the soothing force. If your kid feels you getting anxious and uptight inside, then that doesn't make your infant child feel any more calm. What you need is to feel calm yourself so that you soothe them. Oh my goodness. Oh my goodness. Finally. Okay. One last. Give me 1 minute. Give me 1 minute. Okay. The Seattle, you know what? Yes, your mind does change as you get older, and people are not nearly as sharp as they are when they get older. And this has to do with their ability for flexible, fast thinking. The Seattle longitudinal study was actually what we call a cross-sequential study. It followed people of different ages for a period of time, and they found that, you know what, not everybody's mind declines. If you exercise and do the cardio, your intellectual decline does not begin until the late 70s. And you know what, not even then for everybody. But they found that the part of your brain that does change in the mid 50s is that your brain gets less flexible and you think less quickly. You still know what you know, your crystallized knowledge doesn't change, but your flexibility of thinking and your speed of thinking changes. Any questions? I apologize. I am so sorry for keeping you late this evening. I will try to be quicker on Tuesday. If you don't have any questions for me, I'm going to tell you to take care. I'll see you tomorrow. If you have any questions, don't hesitate to send me an email or send me a text. Take care and have a great day.
Your call cannot be completed as dialed. Please consult your directory and call again, or ask your operator for assistance. This is a recording.